Hey everybody, welcome to the reproductive system. We're doing about chapter 27 in our anatomy books. We're going to start with the male anatomy and then we'll go into the female anatomy and physiology of everything. So let me share my screen. Maybe. There we go. Okay, I think we got it. All right. So we're on the reproductive system. And what's interesting is that there's a lot of the same stuff that goes on between men and women, believe it or not. Although we're so different from each other, but still there's a lot that happens together. So one of the things is that in both cases for men and female, both reproductive systems are on standby until puberty. They're inactive. That happens with both men and women. They both form gametes. Sperm is the gamete for the male, and ova or ovum is the gametes for females. We both bring gametes together through sexual intercourse. They're both sperm and egg combined to fertilize the egg to combine the chromosomes. Another name for sexual intercourse is copulation. They both combine genetic information that contained within the gametes through fertilization. And when the sperm and the egg meet together, it then forms a single cell where both of the chromosomes are combined, and and that forms a zygote. The zygote is the first cell that's combining the two. From there, it then goes through and replicates over and over and over again to form a baby. Okay, number 4, supports and development of the fetus through gestation and birth of the baby, which is called parturition. Okay, now in order to understand how the sperm and the ovaries work to form that zygote, we have to differentiate between mitosis and meiosis. Mitosis is where everything, pretty much all cells in the body go through mitosis. The only cells that don't go through mitosis and go through meiosis are the sex cells, the ovum and the sperm. So ovum and sperm. And this is everything else. Okay, everything else goes through mitosis. All right, so let's talk about this a little bit. Mitosis, there are 4 stages in mitosis, where the first stage is prophase. Prophase is where you have, here's one set of chromosomes right here, let's just say. Prophase is where it replicates those 2 chromosomes to form an identical match of those 2 chromosomes. So it's replicated, but it's they're identical. Okay, there's no change when it's duplicated. Whatever genetics are inside those chromosomes, when it's replicated, the same genetics are passed on. And the next phase is metaphase, where these chromosomes start to line up in the center of the cell there. And then what happens is think of like a sword going through the middle of this cell, and it divides those chromosomes in half, where now you have half of the green guys here and half of the purple. Sorry, and the same on the other cell. Sorry, they're identical though. So the daughter cells of the original cell are all identical. So now the 2 cells that were divided, they now are identical. There's no change in the genetics. And this is how every single cell in our body works. It all goes through mitosis. So the same genes are passed on and on and on as our cells divide. And this is going on throughout our entire lives, I might add. We're always going through mitosis of cells, always. It never stops, not until death. And anyway, in our genetics, from the time we were a zygote, nothing's changed. It is all the same genetics. Now, with meiosis, this is a little bit different. This is where you have a replication of the cells that turns into either ovum or sperm. Okay, so with meiosis in prophase, you have instead of replicating a set of chromosomes just like is seen here in mitosis, instead you have a tetrad that's formed where you have these two guys grouped together, and then they form that group right there. Okay. And then from there, they line up differently in metaphase 1. Okay. It's not lined up in a row like in mitosis. And there's a reason for that because at this point, when the egg starts to divide, the cutting of the middle is going to be down the middle that way, where now you have this green guy over here, this purple guy right there, and then this purple guy over here, and that green guy down there. Okay, so it divides one time. That's meiosis 1. Then it goes through meiosis 2, a second division. Okay, where now this egg, let me change colors, is now divided in half this way and this way. So now you have this half of the green over here, this half of the purple there, and the same thing, the half over here and the half over there, and then etc. like on the other side. So what you end up having is instead of two identical chromosomes in the cell, you only have half. You only have one. Okay, so it's half. And instead of having 2 cells with mitosis, you now have 4. And every single one of these 4, every single one, they all have different genetics. There is no identical genetics, not like mitosis. Mitosis, everything is identical. In meiosis, that's not true at all. It's every single one of those cells is now different from each other, and none of them are the same as the mother cell. Okay. All right. And each one of those daughter cells in meiosis 2, that will either be an egg or that will be a sperm. So that's how you get a variety of genetics. And that's why you can't predict what child is going to be like, what hair color, eye color, a whole bit, because every single one of these sperm are different. And same with the eggs. Okay, so here's an example of the differences between mitosis and meiosis. The number of divisions in mitosis is there's only one division. Remember, it's just this. It's just this one division right here. Whereas in meiosis, you have 2. You have meiosis 1 and meiosis 2. Okay. In mitosis, you have the tetrads that form in meiosis, whereas in mitosis you don't. So you got this thing going on up there, and you have 2 diploid cells or daughter cells coming from the mother cell. In meiosis, you have 4 coming from the mother cell. And then roles in the body for mitosis is for the development of multicellular adult from zygote. So from the zygote cell, the single cell of that person, from that moment on till the end of life, you have nothing but mitosis going on until you start, till you need the sperm and the eggs to be multiplying. That's where you start getting meiosis. Okay. So that's the only place you're going to see meiosis is in the sex cells. This is just an example of how you can have the mother cell, where the mother cell can look, here's one possibility and here's two possibilities, but they come out with all different kinds of ways, shapes, and forms. Okay, just showing the variety of what can come out. We've talked a lot about this already in the endocrine system. This is the actual hormones being released from the pituitary. Starting at the hypothalamus, way up here, you have GnRH. That GnRH then goes down into the pituitary, and it's the anterior pituitary, which then creates, we've got luteinizing. Oh, I didn't spell that right. Silly me. Hang on, let me do that. Okay. Luteinizing. H is going to be hormone. And then follicular stimulating hormone. Hopefully you can read my handwriting. Okay. All right. The anterior pituitary creates those, produces them, and then they're released to go to the gonads, which are the testes or the ovaries. And then from there, it depends. If you've got too much hormone going on and you need to hold off on releasing the sex hormones, then you'll have an inhibition set where you'll have the message go to either the pituitary or even up to the hypothalamus to either slow down, or you have the messaging of, hey, we need to kick this into gear. We need to have more hormone released. And so it's going to produce more. And then it gets to the target cells, like could be the secondary sex cells, like hair growth, things like that. Could be a lot of different things. All right, we're going to look at some of the anatomy of the male. The biggies that I want you to remember is that you have this spermatic cord. You've got obviously the penis. You have the scrotum, or not. You don't need to know the septum of the scrotum, but cremaster muscle, the scrotum. You have the testicular artery, the vas deferens. You got nerves in there. Pampiniform venous plexus. That's the vasculature that is going through the spermatocord. We'll cover in detail the testes in the next page, I think it is. Anyway, one of the things I wanted to show you though in this is that a couple of things. In the spermatocord, okay, so this little cord, I don't know if you can see that or not, right there, and it's on both sides, right? That has a lot going through there. You've got the cremaster muscle in the spermatocord going through there. You have a huge artery and venous plexus going on in there, that pampiniform. You have nerves. There's a lot going down in that cord, and that cord is a fairly thick cord. And then at the very end of it are the two testes that are in the scrotum, which is nothing more than a sac. All right, cremaster muscle, let's start there. Cremaster muscle does the job of making sure that the sperm do not die. So if it's hot outside or you're in a hot shower or bath, the cremaster muscle is going to relax, dropping the testes down, and that sac is going to drop as low as it can go. Why? Because the sperm need to be 3 degrees cooler than the body temperature. And that temperature needs to be maintained around that same time. So you got to cool it down. So that's why the testes are way down away from the body and they're in the sac. It's to cool it down. As it gets cold outside, or the male is cold, the cremaster muscle is going to contract, and when it contracts, it draws that muscle up and draws the testes up closer to the body to get them warmer. I also want to mention just briefly also the let's see, this right here, that thing right there. Okay, the cord has to go through a membrane. That membrane is what's separating the abdomen from the contents of the scrotum. And so this cord goes right around, goes right through that membrane, but the membrane is supposed to be tight around that cord. Oftentimes what men will have is that through work or injury or whatever, just wear and tear of the body, this membrane here will become maybe torn or just loose around that cord, and so the opening will be bigger. Okay, and when that opening is bigger, that is what a hernia is. That's the groin hernia that men often have. That hernia, if that membrane is ripped enough, you could have small intestine that goes through that herniated membrane there. And when that happens, you could have risk of intestinal strangulation, which can be death. So it's very serious to have these hernias. You need to get them repaired as soon as possible. And if you don't, it gets harder to get them repaired as you get older, especially if they go for a long time. I have stories about this that I don't have time to do right now, but maybe I'll have time. If you ask me, maybe I'll tell you about my hernia stories because they're pretty intense, these surgeries I've been in. Anyway, so when a male turns and coughs, in some kind of physical, what the provider is doing is they're putting their finger up pretty much against the penis there, and they're feeling to see if there's any tear or loose membrane there at where this spermatocord goes up into the abdomen. Because if you turn and cough, you'll have some small intestine that can bulge down into that hernia. And that's what you're feeling for. You're feeling for if there's a herniated, if you're feeling anything that might be dropping down into this kind of this hole, this canal. And that's the whole purpose of that. And you have to check both sides pretty much, because both sides can have groins. You can have one on one side, one on the other, or both sides. Doesn't matter. It just depends on the injury of the area. But like I said, if you've got him, get him repaired. So that's what the hernias are. Okay, just so you know. All right, we're moving on. Okay, let's talk about the testes really fast. Testes is where the sperm is going to be made. The sperm cells are produced in the tubes called the seminiferous tubules. That's these guys right here. Okay. And then the interstitial endocrine cells right there, which cover the seminiferous tubules, and they produce testosterone. Okay. You'll need to know all this. Testosterone. Okay. So seminiferous tubules produce the sperm. Okay. That's an arrow, by the way. I don't know if you could tell. Anyway, and then the interstitial endocrine cells produce the testosterone. So in this cross microscopic view, inside, this is the seminiferous tubule right here. Inside, you can see all these sperm cells in here, and you can even start seeing the tails that are starting to grow inside of there. Okay. Anyway, that's where those are all productions of sperm. The sperm will then leave the tubule. Here, I'm not very good at my colors, huh? They'll start to leave the tubules and they'll start entering into the epididymis. Okay, so you've got the head of the epididymis, you've got the body of the epididymis and the tail. So from the seminiferous tube, the sperm start to swim and go head on out into the epididymis. It is there that they will continue their development. It takes about 25 days for them to develop into a full functioning sperm. They learn how to swim in the epididymis, and it's at the back of the testicle. So if you were looking at this picture, this is the anterior, and this is the posterior of that testicle. Posterior in the scrotum. A lot of times, men they'll have pain there at their testicle, and that pain could be pretty sharp. It could be like 7 out of 10 type pain. Oftentimes they'll have epididymitis, which is inflammation of the epididymis. And that could be caused from injury or infection. And so all you have to do is treat it. Even sometimes you can just let time take its course, with some Advil, depending on what's going on, if there's an infection or not. But a lot of times it's the epididymis that's affected by that. What you have to really watch for is torsion. Torsion is where the testicle will actually twist, and that spermatic cord will be twisting as well and will cut off blood flow to the testes. That's 10 out of 10 pain, and that's an actual surgery emergency. That testicle has to be unwound. If it stays twisted like that for very long, it will start to die, and you will be sterile on that side of the testicle. You have two of them, so there is a redundancy there, where if you do lose one testicle, you do have another one, so you can still, get somebody pregnant, but you're down by 50% of the likelihood of getting somebody pregnant. So anyway, either way, you don't want to mess around with that. If it's that much pain, you take them to the hospital. The sperm can be held in the epididymis if there's no ejaculation for several months, and they'll be fine. There is nourishment and nutrition in the epididymis there, so they can stay alive. After a few months, though, they will die and just be reabsorbed by the body. Here's a larger look at that. We already talked enough about it, I think. Here's that cell. We talked a lot about that. Remember, the sperm are produced inside the seminiferous tubule, and the interstitial endocrine cells is where testosterone is produced. Okay. Really quickly, let's look at the life of the sperm here. So this is just showing the role of the hormones and how when the LH and FSH are released from the anterior pituitary, the LH will go to the interstitial endocrine cells and produce what? Yes, testosterone, right there. And then that testosterone then goes and affects the body and everything that does need that testosterone. The follicular stimulating hormone, it will then go and it will go to the spermatogenic cells where spermatogenesis will occur. Genesis meaning birth, and then obviously sperm, so the birth of sperm. And that is all done in this seminiferous tubule. And then you see how the sperm will develop in the in the seminiferous tubule and then released to the epididymis when they're finished, they're growing. Okay. This is just a cell or a slide talking about testosterone, that it stimulates growth of the genitalia to adult size and function. It will produce a male secondary sex characteristics like hair, deep voice, bulky muscle, things like that. It will increase the basal metabolic rate of men. Hence, that's why all men have to do is think about losing weight, and they do, versus us women where it's much harder. And then this is an interesting comment here of brain masculinization, that testosterone will actually also alter the brain to have the person now think like a male, have the desires of a male, etc. All right. And then here we are. This is testosterone in the life of the male. So this is at fertilization. This is when that zygote is created, the single cell. You could see that in the womb, this is the role of testosterone in helping to develop that baby boy. You have birth, and shortly after birth, you do have a push of testosterone. Usually it's because the baby also has a lot of estrogen from the mother, and so it's kind of pushing that estrogen aside. And then through the child's childhood, there's nothing going on with that testosterone. It is being inhibited until it is time for it to be released at puberty. And then you can see it skyrockets, it sustains itself up high, and then towards end of life, it might decrease down to 50%. Unfortunately, today we talk about this a lot. You have low testosterone, and it might even be younger than 60 years old. But the role of men is that they can get a woman impregnated to the day they die. That is what the normal male anatomy should do. Does it nowadays? It's difficult because of low testosterone and erectile dysfunction. Here's a really good picture of the role of meiosis in making sperm, where you have the stem cell up here. This is your original stem cell. It's going through mitosis. So it's normally creating diploid cells, two identical diploid cells of the mother stem cell. However, from there, this cell now goes into meiosis. He goes through meiosis 1, where it divides for the first time, and then it goes through meiosis 2, where it divides again. So now you have 4 early spermatids. That's the early form of the sperm, until you get late spermatids, and then you can see that there's 4 of them, and they're all 4 completely different genetically. None of them are identical. Okay. Here's another picture of the kind of the evolving of these sperm, where you start off with your stem cell here. It goes through mitosis, and it will divide. Here, it'll divide into 2 cells, 2 daughter cells through mitosis. But then these cells then go through meiosis, okay? And this is meiosis 1. I probably shouldn't be using pink, but this is meiosis 1, and then they divide again to form with meiosis 2, and then those early spermatids then eventually develop into the sperm, where they are now able to swim away. Okay, we already went through this. And there's these are all tails that are inside of this seminiferous tubule. So out here in the interstitial fluid is where the testosterone is going to be produced. While the seminiferous tubules, that's where all the sperm are, and you can see all the crazy tails in there. Is that interesting? Okay. I really like this picture too. So one of the things I wanted to talk about, and this probably be the last slide for this video, is you got the development of the sperm, where remember you're starting off. Okay, so you finished your meiosis 2. You're now at the late spermatid stage. Okay, and then you start having this cell starting to develop more, and you start having these groups of mitochondria here, and they start to kind of start gathering together. You also have the beginning of the flagellum there, which is going to be the tail. All right, and there's that mitochondria, and it's starting to form. Up here in the head, all of that head area there, that's the genes. That's the genetic code, is the head. Everything else is just to support the sperm to get to where it needs to go. But then look at this mitochondria. This is like crazy. Okay, here's your mitochondria. Look how it now forms along the side, just below the head, up at the top part of the tail. And that will then become this structure right here. Why do you think that the mitochondria is doing that? Mitochondria are the powerhouses, right? That mitochondria there is because it is the engine or the battery of that sperm to make sure that this tail has the energy and the engine to be flipping around so that it can be swimming through the liquid to get to the eggs. So that mitochondria being lined up like that is there to literally make sure that that sperm never runs out of energy to swim. It's crazy. I just think that's amazing. And then the head, that whole thing is just, all it is just genes. That's all that is. Okay, I'm going to stop right here, and then we'll continue on with the anatomy.